All right, good morning, everyone. I'm very excited to be here at Microservices Day. My name is Sean Smith, and I'm a principal engineer at Gilt Groupe. I worked with Gilt Groupe for about 4 years now, and at Gilt we use microservices, and we have evolved our platform over time. So I'm here to give you a talk about how we have sort of progressed along our path. So for those of you that don't know, Gilt Groupe is an e-commerce site that sells luxury brands online. We actually shoot products in our own studios, and we receive inventory in our own warehouses. And most of our sales start around noon, which leads to an interesting sales pattern or traffic pattern for us, where since most of our sales are around noon, we have this giant noon traffic spike as all our customers rush to the site to buy stuff, and then tapers off throughout the afternoon. Now, this story begins back in 2007, where we essentially had a monolith. Everything was served from this giant Ruby on Rails application. There were some minor optimizations with Memcache, but essentially it was a Rails application speaking to a giant database. And this had a number of problems. So our development was starting to slow down, and our deploy strategy was like once a week, which involved a lot of merges across various teams. So it was making it harder and harder for us to innovate. So we were asking ourselves, how can we arrange things so that we can actually quickly deliver on new features and functionality? And that's where microservices came into play. So we took a long, hard look at where our traffic is actually coming from, and took a look at the traffic funnel, and essentially broke it out into a few key places, like login and registration obviously gets a lot of traffic, versus checkout gets lesser traffic. And we decided to break out our initial microservices that way. So across the bottom there's some backend services that are part of that funnel. And then on the front end, to innovate faster as we were launching new initiatives, we had arranged our teams by business unit. And so each team was responsible for their front end stuff. But over time, we noticed that while it was great for getting first to market and getting features out for a given silo, it wasn't great for long-term maintainability. An example being what happens if you want to redesign the entire site and make it consistent. Well, since we have 5 silos there, it's 5 teams doing a whole bunch of work. And we decided that was not great. So again, we took a look at our stack and decided what portions we were going to extract out. And then we eventually got to where we are today, where the front-end portions are, again, aligned by functionality. So we have portions for our search, for displaying products, for checkout, for our loyalty pieces, et cetera. And we have a large number of microservices on the back end that supports that functionality, as well as all our legacy services at this point. And these cover a large amount of functionality, from checkout to fraud to loyalty to login and registration. And you can sort of really see where we decided to double down on microservices there, where there's this big dogleg where just the number of services we have in production has grown a lot. So as of probably yesterday, we're probably sitting around 250 microservices in production. And we deploy a lot. So this is our deploy pattern over the last 2 years with our deploy tools. And on average, we actually have 50 successful deploys of our services every single day. So the driving forces behind our architecture has essentially been allowing teams to do the things they need to do to deliver the value they feel they need to deliver. And to do that, obviously making it easy to deploy and iterate over things, and giving them the opportunity to fail or deliver. and to go out and try stuff and then come back and review. So to quickly recap our architecture, we went from a monolith to a few microservices, and then as we had problems scaling those services, we further split apart our architecture. So yes, we love microservices at Gilt. We feel it lessens dependencies between teams and it allows them to innovate quickly. It allows us to do lots of things in parallel and allows us to try using new techniques and languages and frameworks. And there have been times where we have gone and tried stuff and it hasn't worked out, and shutting that down is as easy as just shutting down that microservices, which is pretty great. But of course, it hasn't come without its challenges, and I'm here to be open and honest about some of the difficulties we've encountered and how we've tried to address that. So let's think about monoliths for a second. When I've heard microservices talks, I usually hear monoliths in terms of monolithic services, but there's also other monoliths inside of tech organizations. There's monolithic databases, and there's also monolithic libraries. So for example, you might have a commons at your workplace, which is a place for a bunch of commons code. At Gilt, we started out with a commons as we were moving from services, essentially parsing JSON as maps, to starting to create clients. And all those clients initially ended up in this one place called Commons, which at the time was great because it was an easy way for the front-end teams to get all the clients they could need to talk to their back-end components. So this contained a lot of things, but it was starting to become really intertwined, and we realized that this is probably not the best approach. And we recently actually did an audit of how many services are using our Commons library, and it turned out to be quite a bit. So there's about 70 instances of, or different versions of Commons in production across a multitude of services. And actually, this is probably worse than having a monolithic server, because presumably some of these are actually bug fix versions. So looking at this, how do you know what bugs are actually fixed in your code base, or what services are calling which code? You really don't. And so we decided we had to scale back. We had to fix this somehow. So we did two things essentially. So we did this big upgrade where we spent time actually breaking our commons down from a monolithic library into specific libraries, which is exactly what you do with a monolithic service that you want to break into microservices. And then we also did a small project where people would go through and upgrade to sane versions to cut down on that big list. And then so after about a month of work, we ended up with this, where as you should be able to see, there are much fewer instances of commons in production. Most of them are edging towards the newer versions on the right, and then there's that other big spike, which is the latest stable version of our 5.x branch. And that gave us a lot more confidence about that set of code in production, which is very important when you have 250 services in production. So around the time we decided that Commons was bad, we decided that we still really like strongly typed clients, but we were going to go about it in a slightly different manner. So we ended up doing this thing called client-server core. So you have your client, you have your server, and you have some core in the middle, which generally houses the models that the server and the client need. And that sparked a lot of new thinking. mostly around testing. So we accelerated in a direction where a bunch of our testing was actually going to use the client to exercise the server code. So then you know that your client is actually correct versus deploying and then a bunch of clients breaking. But there's problems in this strategy as well, which is essentially to a degree the same problems with that big commons monolith, where because of our deploy strategy, all those were in one repository. So whenever we did a server release, the client version was also incremented. So then, if you're just looking at your dependencies, you're not really sure if that client actually introduced new logic. So some anti-patterns I feel in that are monolithic libraries are just as bad, if not worse, than monolithic services. The fact that versioning of libraries that have no real meaning, because version 5.1.1 might actually be identical to 5.4.0, and it leads to this pattern of always be updating. And you don't really want your team to be focused on updating dependencies that may or may not have any versions. You actually want them focusing on delivering new stuff. So how to avoid, for starters, thinking about the domain of your clients and your library code, and then for the specific problem of the versioning, we've started moving towards lightweight service clients. So at Gilt, we've settled around REST-style APIs, and recently the founder of Gilt started work on this project called API Doc, which its goal is to provide documentation as well as automatic generation of some very dumb zero dependency clients. And the way it works is you essentially write some JSON that models the various models and resources that your service is going to use, and then you can upload that to API Doc, which generates some nice documentation outlining everything that you can click through. As well as generates a bunch of clients for you. So right now it generates some Play clients, a Ruby client, and a very bare Scala client. It's actually possible to plug in your own code generators. So if we decided that we wanted to use Node at Gilt, which some people are actually experimenting with, there would be no reason why they couldn't generate essentially a generator to generate Node clients, and then all the services that are in API Doc now would essentially get those clients for free. And there's some other advantages to this. For the big one for me is that it's driven us towards API-driven development. So rather than going and starting out your service and getting into production and iterating, this has led us to sit down and actually think about our API more, and actually sit down and figure out what interactions people are going to have, and actually even let people or essentially open up your API for discussion for your consumers. And API Doc actually allows people to subscribe to new projects as well as changes. So anyone who is interested can actually get a notification when there are changes to an API. And this has led to some really good stories. So in the early days of API Doc, there was a project where we were integrating with a third party, and the team involved in that was going to write their own code for essentially marking orders shipped. I was like, whoa, hold on. I was working on the team that essentially owned that sort of functionality, and I was like, I already have an API that does this for you. Let me write you up an API.client, and as long as you use this client, I will guarantee my software works, and you won't have to write it. You won't have to write any complicated or processing logic. And then that team in turn wrote their own API.client and gave it to the third party and said, as long as you use this client, I will guarantee that this code works, and you won't have to write your own logic to do so. And so we all went our separate ways for 2 days, and so various people could write their various implementations after just writing the API doc, and then we came together to do an end-to-end test, and there was actually one bug, but that bug was just someone's implementation downcasing a string and then another implementation trying to uppercase, and that was an easy bug to fix. And the time to market on that feature was essentially like 2 days. All right, so let's go back to monoliths for a second. So specifically this monolith. So how would we go from something like this to a set of microservices? And I'm going to use waitlists as an example. So we sell things online. Sometimes we sell out. So we have wait lists. People put things on wait lists, and when things get back in stock, we'll send them a notification saying, hey, that thing is now available again. So how would you expect this to look? So you might end up with a design like this, where you essentially have a service that does waitlist management, so people can add and remove and view their waitlists from the front end. And then you might have another service whose job it is to monitor inventory changes and then send out notifications via various delivery mechanisms. So I recently moved to the team who owns this functionality, and when I moved over, I started taking stock of our services, and what I found was the design wasn't like this, it was actually sort of like this. There's 6 services involved for some reason. I was like, that seems like a lot for waitlist, so what's going on here? So on the waitlist management thing, the front end, some parts of the front end still just talk to our waitlist management service, but then there are other parts that talk to this other API that's supposed to be some sort of JavaScript proxy that in itself talks to service waitlist, add things to the waitlist. And then there's this other service that's owned by an entirely separate team that is sort of wrapping our waitlist API for our mobile applications. And primarily because they wanted to add pagination to sort of better control the amount of information that's going to mobile clients, which sort of makes sense, but for whatever reason that wasn't. The choice was to add a new service rather than just add that functionality to service waitlist. And this is bad for a number of reasons. So now we have 3 APIs for waitlists, which is not great. For anything going through those proxies, there's additional latency for all your requests, which depending on what your service does is probably or may not be a big deal. And just trying to make changes at the base layer now means that, to a degree, you have to check that many more dependencies upstream. And then on the notification side, we sort of have the same thing. So there's this additional notification service that was owned by the mobile team because their thinking at the time was this functionality we want to introduce is primarily for mobile, and we're going to be deploying it. So we should just start up our own microservice to manage it, because we just made it so easy to spin up new microservices and deploy them into production. Yeah, for whatever reason, we ended up with 4 services owned by my team, and 2 services ended up being owned by mobile. And then this actually caused a problem. So this is actually a graph of the number of waitlist notifications we've sent over a 4-week period. So you might notice there's a dip there, and that's because a bug was deployed, and the mobile's notification service, specifically, they were starting to mark waitlist items as notified, even if the person didn't have a mobile device, which meant a lot of people did not actually receive a notification that waitlist items were available, and that caused a revenue impact on us as well, because fewer people are seeing waitlist notifications and being like, oh, I need to go and buy that right now. And then farther to the right, where we deployed a fix, and that fix was actually to tear down that waitlist, that mobile waitlist notification service, and move that functionality into the core, because it would essentially it would make it easier for us to notice things that are going on, because we were not privy to the commits going on in that other service, and knowing when things go out, and just having a better grasp of all the interactions rather than flipping between multiple code bases. So right now, waitlist looks like this, where the notification side is simplified, and we're working towards simplifying the management side, which is a little more involved, because there's actual client requests and APIs that we have to deprecate. So some anti-patterns here. So there's a bunch of services in the same domain per consumption channel. So Team A is working on their part, and Team B is working on their part. They may or may not be talking about what they're doing. And because there are so many services there, it was essentially starting to strain and perhaps even break the limits of working memory, which, for those of you who don't know, is the theory that everyone can keep 7 things in mind, plus or minus 2. And when we're talking about things like microservices, which may have complicated interactions, I would definitely err on the -2 side of that. And then there are services, wrapping services, which leads to additional complexity, as well as a deeper call stack, which can eventually be problematic as you're scaling out. So to close off, just at Gilt, we aim for microservices to be well-defined, easy to understand, and loosely coupled. We occasionally like to go through and review what we actually have in production to make sure those things hold true. And when we don't, we go through and we take steps to improve it for our future selves. And I mean, if I could tell you one thing, when you're going to microservices, I would say to keep things simple, and your future selves will thank you. And that is it.